Alright, let's take a second just to review. So when we label a triangle, the angles are capital letters, and the sides opposite the angles are the corresponding lowercase letters. So if I make this angle, angle A, the side opposite to it will be side A, but it's lowercase. If I make this angle B, the side opposite to it will be lowercase b, and this is angle C, this would be side lowercase c. Sections 3.1 and 3.2, exploring side angle relationships in acute triangles and the sine law. So, an acute triangle is a triangle in which all the angles are less than 90 degrees. So, take a look at the triangle to the right. How can we find angle B? Well, we can't use the primary trig ratios because we don't have a 90-degree angle, and we can't use the Pythagorean theorem because we're dealing with an angle. So there's really no way that we can find it. But we're going to prove this thing called the sine law. Okay, the first thing we need to do when we're trying to prove a law like this is we have to figure out some way that to use our prior knowledge, so to use our primary trig functions. To do this, I added the height. Now the height of a triangle forms a 90-degree angle inside of an acute triangle. That means that I now have two different triangles that are both right angle triangles, and I can use my primary trig ratios within this. Alright, so first off, write two equivalent expressions for the height h and use these to create equivalent ratios, starting with the sine of b. Alright, so here's angle B. Sine is opposite over hypotenuse. So my opposite side is h, my hypotenuse is c. So sine B equals h over c. Then I can solve for h by multiplying both sides by c to get c sine B is equal to h. Next, I'm going to deal with the sine of c. So here's angle C. Sine C equals h, or the opposite, over b. Sine C equals h over b. I can multiply both sides by b. To solve for h is b sine c. Then, by the transitive property, because h is equal to c sine b, and h is equal to b sine c, I can set them equal to each other. So b sine c is equal to c sine b. Then I can divide by b on both sides. It will cancel it on this side to get sine c is equal to c sine b over b. Then I can divide by c on both sides. These will cancel. I end up with sine c over c is equal to sine b over b. Because these are ratios, you can actually flip them, and it's exactly the same. So it'd be c, the side c over the sine of angle c is equal to the side length of b over the sine of angle b. But what about side A and angle A? So we simply draw another height in our triangle. This is the height I drew this time. And we repeat the process. So sine A is going to be opposite over hypotenuse, h over c. Multiply both sides by c. We get c sine A is equal to h. And then we're going to work with angle C. So sine of C is opposite over hypotenuse. So I have h over a. Then I multiply both sides by a. A cancels out there, so it'll be a sine C is equal to h. Again, by the transitive property, I can say that because they're both equal to h, they're also both equal to each other. So c sine A is equal to a sine C. Then I can divide by a on both sides to get c sine A over a is equal to sine C. Next, I can divide by c on both sides to get that sine A over a is equal to sine C over c. Again, I can flip them to get a over sine A is equal to c over sine C. Now, because of the transitive property, I can also say this is equal to b over sine b. That is a proof for the sine law.